All right, so the next part of our notes here that we are going to get into in terms of the integumentary system in the skin is we're going to take a look at the dermis, which is the layer just deep to the epidermis that we learned about last week. And the dermis is made up mostly of connective tissue. So again, here is where I want to work in a little bit of histology into this unit by including the connective tissue, some characteristics of connective tissue, and then we'll talk a little bit about the one type of connective tissue that is found within the dermis. So some general characteristics of connective tissue. Connective tissue binds structures together. It supports and protects structures. It serves as a framework. It fills spaces between organs, between cells. It stores fat. It produces blood cells. It helps protect against infection, and it helps to repair tissue damage. The key that we're looking at here is binding structures when we're talking about the dermis here. So the cells are much farther apart in connective tissue than they are in epithelial tissue. If you remember when we talked about the squamous epithelium, all the cells are packed tightly together right next to one another, and that helps to create a nice waterproof barrier. But now we're deeper. This isn't a barrier layer. This is a binding layer. There's a lot of space between cells. So the cells are sitting with all this space around them, and all this space is filled up with protein fibers and all kinds of other things that we're going to take a look at. So let me just pop this up here like this. Okay. So there's lots of what's called extracellular matrix. It's got all these protein fibers and then what's called a ground substance, which is proteins that aren't fibers, right? Like aren't rope-like proteins. They could be shaped like spheres, all kinds of other shapes, but they are not fibers of protein, not long rope-looking proteins. There's also going to be some other molecules and some fluid filling in that ground substance. Now, the ground substance consistency varies based on where it's found. It can be fluid, it could be semi-solid, which is kind of like a gel, or it could be solid. Blood is a connective tissue. So you've got all these red blood cells floating through your blood vessels, and they're in a fluid of extracellular matrix. All that space between blood cells is filled with the plasma, which is the fluid extracellular matrix. We have the gel-like ground substance, and that is going to be what we have in the dermis, with the connective tissue in the dermis. And then solid connective tissue would be like in bone, where you've got the solid extracellular matrix. You've got bone cells with a lot of space between them that is filled with that calcified material that makes the extracellular matrix solid. So the extracellular matrix is this area outside here between the cells. This is the inside of a cell, and there's all this space here that between cells. That's going to be your extracellular matrix. This is what connective tissue looks like under the microscope. So you've got some different kinds of cells that we see here that we're going to talk about in just a minute that are all spaced out, and then you've got all this space between them that's filled with protein fibers and other molecules filling that area between all those cells that are very far spaced apart, unlike in the epithelial tissue. Most, in terms of connective tissue, most connective tissue can divide. Most have good blood supplies. Some are very, very rigid, like bone and cartilage. Some are a little more flexible, like loose connective tissue. That's what we're going to see when we take a look at the type of connective tissue in the dermis. So those are some just miscellaneous characteristics. The types of cells we're going to find in the connective tissue. There are some that are fixed, so they stay in the tissue for a long time. And then there are others that are wandering, that kind of move throughout the tissue. They show up temporarily, usually due to injury or infection. They move into the area, they help clean out the injury or infection, and then they leave to go help somewhere else. Okay, so the most common type of fixed cell in connective tissue is called a fibroblast. And these are the ones that produce those protein fibers in the extracellular matrix. The suffix blast means to generate or produce. And so what they're generating or producing are these protein fibers, hence fibroblasts, generating fibers, and they're protein fibers. So here we see these are the fibroblasts here that are generating all these protein fibers around them, made of the protein collagen, which is abundant in your skin and in your lips, for example. There's a lot of collagen. Some actors and actresses get collagen injections to make their lips look fuller because you lose collagen as you age. There are what are called macrophages, which originate as white blood cells, part of the immune system. They're almost as common and numerous as fibroblasts, but these are wandering. So these are helping to fight injury and infection. So they move into an area where there is an infection, they help clean it up, and then they leave to go somewhere else. So they clear foreign particles. Out of your connective tissue. And so in this picture here we can see a macrophage. Macro meaning large, and they are mobile. They move around and clean out infection. You can see macrophages here in this extracellular matrix. There are also fibroblasts and all these protein fibers. So this would be some connective tissue in this slide. There are what are called mast cells, which are very large and widely distributed. They're usually found near blood vessels, and what they do, they release a couple of molecules. They release one called heparin that helps to prevent blood clotting, so they keep blood flowing to an area. And they release histamine, which promotes the reactions that you see with inflammation. Whenever you get like an area where you maybe got a little splinter and you notice it gets red and swollen, histamine plays a large role in that. It also plays a big role in allergies as well. Okay, so mast cells you can see in this picture right here. The types of fibers found in connective tissue, right? The protein fibers in the extracellular matrix, then there are what are called collagenous fibers, elastic fibers, and reticular fibers. Collagenous fibers are thick threads of the protein collagen. They are flexible, but they're not very elastic, so they can bend, but they're not going to really twist and stretch a lot. They have great tensile strength, so they resist the pulling. And they are an important component of body parts that hold structures together. So they're an important part of ligaments and tendons, okay? So here's a fibroblast, and then all this pink around it are the collagenous fibers. This would be a section through either a ligament or a tendon. Elastic fibers are made of the protein elastin. They are weaker than collagenous fibers. They are easily stretched and deformed. And they are found in parts of the body subjected to stretching, such as vocal cords. Under the microscope, they appear yellow. They're referred to as yellow fibers. And so you see them here. They are these much thinner protein fibers running through the extracellular matrix. The collagenous fibers are much, much thicker. Okay. And the last type of protein fiber in the connective tissue are these reticular fibers that are very thin collagenous fibers, and they're branched, okay? So when we talk about collagenous fibers, they're the very thick, unbranching protein fibers found in connective tissue. But we also have these reticular fibers that are also made of collagen, but are much thinner and are very highly branched, and they form the supporting network in many tissues, such as in the spleen. All right, so we are going to be taking a look at one type of loose connective tissue here, and that is the areolar connective tissue that is found in the dermis. This is delicate and thin connective tissue. The cells are spaced widely apart. They have a gel-like ground substance. We will see both collagenous and elastic fibers within areolar tissue that serves to bind skin to organs. So if we are lucky enough to get back together in the spring and get to do our big dissection, which is a rabbit, you will have to take the skin off of the rabbit. And to do that, you'll have to peel through the areolar connective tissue to separate the skin from the organs underneath. It also fills spaces between muscles. It lies beneath epithelium. It has lots of blood vessels running through it. So this is your areolar connective tissue, what it would look like under the microscope. These are the nuclei of fibroblast cells. You can see these thick collagen fibers running through it, and these thinner elastic fibers as well, okay? And all the rest of this surrounding area is the ground substance with other types of proteins and other molecules and ions filling that space. But the main proteins are these thicker collagenous fibers and thinner elastic fibers. So your dermis is strong, flexible, connective tissue. It is your hide. That is when you buy leather that's made from a cow, that is the dermis that has been tanned and hardened. Okay, we're going to see fibroblasts, macrophages, mast cells, and white blood cells within the dermis. We're going to see collagenous fibers, we're going to see elastic fibers, and reticular fibers within the dermis. It has a rich supply of nerves and blood vessels. It plays a critical role in temperature regulation because the blood vessels that dilate when you get too hot or constrict when you get too cold, those are found within the dermis. And then there are two layers. There's what's called the papillary layer, which is the more superficial of the two layers of the dermis that's made of areolar connective tissue. And it includes these little bumps called the dermal papillae that actually give us our fingerprints. And then there is the reticular layer that has a bunch of collagenous and reticular fibers running through it, and that is deeper. Okay, so here we see the dermis. This is a cross section through the skin. Up here is the epidermis. This middle section here is the dermis, and the uppermost layer is the papillary layer. This deeper layer is the reticular layer. And we can see a lot of the appendages of the skin. We can see hair follicles, sebaceous glands, sweat glands. We can see nerves. We can see the erector pili muscle, right? And we're going to talk about all those things, but those are all found within the dermis. We're going to talk about those with the next video here. The papillary layer has these little bumps that project up into the epidermis. You can see all these little bumps here. Those little bumps create ridges in your fingers. Those actually create your fingerprints, and they are called the dermal papillae. So you can see here, if we were to peel the epidermis off, first that would be extremely painful, but if we were to actually, if we were just do it in this picture, you peel the epidermis off, you see these little bumps sticking up in the papillary layer. Those are called the dermal papillae. Okay, and then deep to the dermis is the hypodermis. This is not technically part of the skin. It is made up of a type of connective tissue called adipose tissue, which is a fancy way to say fat. Okay, so here's a slide that shows you the epidermis and dermis. Here you can see the dead cells that are filled with keratin of the stratum corneum. This is the rest of the epidermis here. This is the papillary layer, this uppermost layer with the dermal papillae pushing up into the epidermis. The epidermis is all this darker pink, and this lighter pink with all the collagenous fibers. This is the dermis. So this uppermost layer is the papillary layer. This deeper layer is the reticular layer. Okay, and then the papillary layer contains our fingerprints. And your genes that you inherit determine your fingerprints, but the environment that you're in the womb or in the uterus also can change your fingerprints slightly. And that's why twins actually have different fingerprints, okay? The papillary layer is made of this areolar connective tissue that you see in this picture, whereas the reticular layer is similar to connective tissue, but the dense regular connective tissue, but the collagenous fibers are not as neatly aligned. So what you really need to know, it's got a lot of collagenous fibers and it has some reticular fibers running through it as well. Okay, and then this slide here has just got a picture of thick skin on the left, thin skin on the right. There's one big difference between the two, and that is the stratum lucidum is found here in the epidermis of the thick skin, but not in the epidermis of the thin skin. Okay, but you can see again, your papillary layer is this uppermost layer here that's made of the areolar connective tissue. And then you can see where it kind of changes. We can see these orange, thicker fibers down here made of collagen. And that's where you've got your reticular layer down here a little deeper. Starts to look a little different under the microscope. Okay, and that's where I'm going to stop for today. Next time, we're going to talk about skin color and what produces the different skin colors that we see in humans, and then we will get into the appendages. We'll talk about the hair, the sweat glands, and the sebaceous glands that we see when we take a look at the skin. So that's it for today. Have a good day. I will see you in 2 days.